Hello everyone. Today we are going to discuss the question based on work and time. In the part first, we have discussed the individuals. Wherever individual person were doing the work and they themselves will complete the work. In the part first, we have seen the problem where individual join after some time, individual leaves the work before the completion of time. Such problems we have discussed in the part first. So in the part second we are going to discuss where multiple identities like X number of men, Y number of women and Z number of boys, they will do the job. So let's discuss the problem. In mathematics we have to practice more and more. Only then we will understand and learn the problem. So in this session we are going to discuss 5 questions. So let's go to the first question. Six men can complete a piece of work in 12 days. 8 women can complete the same piece of work in 18 days. And 18 children can do the same work in 10 days. 4 men, 12 women and 20 children do the work for 2 days. If the remaining work be completed by men only in 1 day, how many men will be required? In work and time, if n number of persons are doing a work in particular number of days, then individual person will take more days. Like in this case, 6 men can do a piece of work in 12 days. So one man, how much time he will take? 12 into the 6, 72 days. So let's go to the solution. Here the 6 men are completing work in 12 days. So one man will complete the work in 72 days. 6 into 12. And the 8 women are doing the work in 18 days. So one woman will take 8 into 18 days. And then we are rearranging the first one. First one man will do in 72 days. So 72 can be written 4 into 18 because 18 is the common factor between all these individuals. So one children will complete the work in 180 days. 18 into 10. So now we will note down the number of days taken by one man, one woman and one children. So one man is taking 4 into 18, 8 into 18, 18 into 10. 18 is the common factor. So it will come in the LCM side. And for the remaining 4, 8 and 10, LCM will be 40. So we will have 720 unit of work, 18 into 40. Efficiency of one man will be 10, one woman will be 5 and one children will be 4. Now 4 men plus 12 women plus 20 children start doing the work. And for how many days they are working? 2 days. So one man efficiency 10, 12 women 5 and 20 children 4. So they will complete 180 unit of work in 1 day. So they are working for the 2 days. How much work they will finish? 360. And the total unit of work are 720. So they will complete 360 unit of the work. So total work is equal to 720. So 720 unit of the work is to be completed, and 4 men plus 12 women plus 20 children, they will do 360 unit of work in 2 days. So remaining unit of work will be 360. And these 360 units are to be completed by the men only, as per the question. So men efficiency is 10, and unit of work is 360. And if it is to be completed in one day, then 360 upon one day efficiency should be 360, but one man has only the efficiency of 10. So to reach up to the level of 360, there should be 360 men to be employed to complete this work. So in this question, 36 men will complete the remaining unit within one day if 36 men are employed. So option A is the correct option. Now we will go to the question 2. Question 2 is little bit easy question. 4 men and 6 women can complete a work in 8 days, while 3 men and 7 women can complete it in 10 days. How many days will 10 women complete it? The question is basically saying that the same work, how many days will be taken by 10 women if those are working that work, same work. So let's go to the solution. Four men plus 6 women. How many days they are taking to do the work? 8 days. And 3 men, 7 women, they are taking 10 days. So similar way, we will find out their efficiency. 8 days and 10 days. 8 days taken by the 4 men and 6 women, and 10 days taken by the 3 men plus 7 women. So LCM of that will be 40. So efficiency of 4 men plus 6 women will be 5 and 4. So efficiency can be compared. So here we will multiply first equation with 3, second equation with 4. So we will be left with the women part because the men will be cancelled when we will do subtraction. So 10 women have 1 efficiency. Efficiency of 10 women is 1. So to do a work of 14 unit and efficiency of 10 women is 1. So number of days taken will be 40 days. So option B is the correct answer. So it will be solved very easily. Now let's go to the second question. Question number 3. 24 men can complete a work in 16 days. 32 women can complete the same work in 24 days. Then 16 men and 16 women started working together and worked for 12 days. How many more men are to be added to complete the remaining work in 2 days? This one is a little bit complicated problem. So number of days are given. First we will find out efficiency as we have done in the previous questions. So now let's go to the solution. So 16 days taken by the 24 men and 24 days taken by 32 women. So we'll take LCM of 16 and 24. I think 48 will fit into the LCM part, and we can consider multiple of 48 also. 96 also we can take as a unit of work. So efficiency of 24 men will be 3, 32 women will be 2. So then 16 men and 16 women started working together. So now the efficiency of 24 men is equal to 3. So 1 man efficiency will be 1 by 8, and 32 women have efficiency of 2. So 1 women efficiency will be 1 by 16. So 16 men and 16 women started working together and worked for 12 days. So we will calculate how many work they have completed in 12 days. So 1 man efficiency will be 1 by 8. So 16 man efficiency will come to 2. 32 women have 2 efficiency. So 16 women have 1 efficiency. So they will complete 3 unit of work in 1 day. So in 12 days they will complete 36 unit of the work. So the remaining unit of the work will be 48 minus 36. 12 balance unit has to be completed. So within 2 days these 12 units should be finished. So to do the 12 unit of work in 2 days, there should be efficiency of 6. So 16 men and 16 women have efficiencies 3. So remaining 3 efficiency we have to increase, because to do this work within 2 days and unit of the work left are 12. So work should be done with the efficiency of 6. 12 by 2, 6. But the present 16 men plus 16 women have efficiency of 3 only. So, so 3 additional efficiency we have to increase. And the question is saying that how many more men are to be added to complete the remaining work in 2 days. So this 3 efficiency should increase with the strength of men. So suppose we are employing n men and 1 man has efficiency of 1 by 8, and according to the solution part of the question it should be equal to 3. So then n will be 3 into 8, 24. So we have to employ 24 more men so that this work can be completed within 2 days. So now we will move to the question number 4. A contractor undertakes to do a piece of work in 40 days. He engages 100 men at the beginning and 100 more after 35 days and complete the work on stipulated time. If he had not engaged additional men, how many days behind the schedule the work should have been finished? So now we will move to the solution part. Student, you try to solve it yourself. In this question, in the end part, we are sure that for the 5 days there are 200 men employed, and then how much work they will complete in the last 5 days. that will be the 200 men and into number of days. They will complete 1000 unit of the work. So in the beginning part of the question, 40 days 100 men will work. So the total work will be 4000, and in the end part 1000 of the work is done. So in the first 35 days, how much work is done? Only 3000 units. So now we will see by the solution. So here contractor engaged 100 men for doing a work in 40 days. So as I told you earlier, total unit of work will be 40 into 100, 4000. Sorry, that instead of 1000 it will be 100. So after 35 days he engages 100 more men to complete the work on time. So we will find out the solution. So for the first 35 days, only the 100 men are working, and for the last 5 days, 200 men are working. So in the last 5 days, how much unit of the work will be completed? 200 into 5, 1000 unit. So in the first 35 days, only 3000 unit completed. Ideally, it should have been 3500 because 35 into 100. So they are lagging behind the 500 unit of the work. So if more men have not been deployed to do this 500 unit of work, how much time will be taken by the 100 men? So 500 is the unit of work upon total number of men. So it will take 5 more days. So contractor is lagging behind 5 days to complete this work. So the option A will be the correct answer. Now we will move to the next problem. 4 men and 10 women were put on a work. They complete 1/3 of the work in 4 days. So basically here 4 men and 10 women employed for a work. They completed 1/3 of the work in 4 days. If they are saying 1/3 of the work is done in 4 days, so how many days they will take to complete the whole work? That will be equal to 12 days. After this, 2 men and 2 women were increased. So now instead of 4 men there will be 6 men, and instead of 10 women there will be 12 women, and they will complete 2 by 9 more of the work in 2 days. So here what we will conclude, then 6 men and 12 women will complete a work in 9 days, because they are completing 2 by 9 of the work in 2 days. So basically they will take 9 days to complete the whole work. Then question is saying, if the remaining work is to be completed in 3 days, then how many more women must be increased? So now go to the solution. So 4 men and 10 women does one third of the work in 4 days. So that means to complete the whole work they will take 4 into 3, 12 days. Then 2 men and 2 women are employed to do the same work. So now there will be 6 men and 12 women. And they are doing 2 by 9 of the work in 2 days. So that means how much time they will take to complete this whole work? That will be the 9 days. Now we have the number of days. So we will calculate the efficiency part. 12 days, 9 days. So work unit we can consider 36. So efficiency of the 4 men and 10 women will be 3. And then 6 men plus 12 women, it will be the 4. So for the first part, they are completing one third of the work. One third of 36 will be 12. So 12 unit completed by 4 men and 10 women. And the next 2 by 9 unit of the work completed by 6 men and 12 women. So they will complete the 8 unit of work. So total unit of the work are completed will be 20. So and the total number of unit of work are 36. So how much unit left? 16 units, and these units are to be completed within 3 days. Then how many more women must be increased to do 16 unit in 3 days? The efficiency should be 16 by 3. But the 6 men and 12 women have efficiency only 4. So there is a gap between the 16 by 3 and 4. So more women should come and increase the efficiency from 4 to 16 by 3. So now we will calculate the women efficiency by the multiplication and subtraction. So men part will be cancelled and we will get the efficiency of women. So by the subtraction we will get 12 women is equal to 2. So 1 women efficiency will be 1 by 6. And efficiency should be increased by 16 by 3 minus 4. So efficiency should increase by 4 by 3, and this should increase by n number of women who have efficiency of 1 by 6 is equal to 4 by 3. So 8 more women should join the work so that efficiency will increase from 4 to 16 by 3 and work will be completed within 3 days. So it was a little bit difficult question. So we have solved 5 questions, and I hope you will practice more and more questions. You can refer any reference book and try to solve more and more questions, because in mathematics we have to do more and more practice. Only that we will have a clarity of concepts. So wait for more educational videos and subscribe my channel. I hope that I will prepare and upload more and more videos. Thank you.